Talk Show.
Recorded live.
Hello and welcome to the Virtualization Security and Cloud Security Roundtable, episode number 98. We're working our way to our 100th episode, hopefully the best of, or maybe just something incredibly brand new. I'm still looking at ideas for that, so bring them along. Our panelist today is Eben Rodriguez, who is an IT industry veteran, now serving as a Cloud Solutions Advisor for CA Technologies.
Hello.
And thank you for joining us, Eben. We have with us also Tim Pearson, who's a contributing author to the VMware vSphere and Virtual Infrastructure Security book, and owner of Data Center Inc., as well as a virtualization security trainer and course creator of various types. And myself, Edward Haletke, a.k.a. TechSciWill on the VMware Community Forum, and just about everywhere else, an author of the book VMware vSphere and Virtual Infrastructure Security, Securing the Virtual Environment, as well as VMware ESX and ESXi in the Data Center, its second edition. And I am working on a second edition of the security book for those that are interested. And also joining us this week is George Reese, who is the founder and CTO of Enstratus, an enterprise cloud management platform. He's written several technology books, including books on cloud computing and REST API design. And that's actually what we want to talk about this week. And welcome for joining. Thank you for joining us, George.
Oh, thank you for having me.
What's come up is that we've talked in the past about cloud security as it looks like from the tenant and as it looks like from the provider, but we really haven't talked about cloud and virtualization security from the API perspective. We're always looking at the network for, oh, this app has to be protected from this app, and this user shouldn't be able to access this virtual machine. So tell us why API security is so important, George.
Well, you know, the first thing is that when you reach a certain level of maturity in using, leveraging cloud computing, especially, you know, when you get below the software as a service layer, so at certainly at infrastructure as a service and to a large degree at platform as a service, one of the primary mechanisms through which you're interacting with those services is through an API. And as a matter of fact, at some level with services like Amazon Web Services, it's entirely through the API, even when you're using their web interface. You know, the interaction, the security of the interactions, you know, boils down to how secure is the API and, you know, protecting the data that's being exchanged and making sure that the person is, or the entity acting, you know, requesting things is the entity that it's supposed to be, and that they're only doing things that they're supposed to be doing.
That's good, okay. And when we look at things like that, right, how do we enforce it?
Well,
given today's technology, you know, we have APIs proliferating all over the world.
Yep.
And there doesn't seem to be any control or any mechanism as the authors of these APIs are trying to make their lives easier, right? That's why they do them.
Yep.
But they're really not considering the security implications of allowing, for example, someone to upload a VMDK or a disk file that has in it, you know, a pointer to a system file, like, Etsy Shadow, for example.
Well, you know,
things that would be really bad.
There are a couple of issues, and you're diving down deep, and there are a lot of more fundamental problems that you'd think would be solved that aren't. And you know, if in the, you know, information security community, we always talk about or complain about how much security is an afterthought for a lot of people. Well, APIs are actually also an afterthought. So API security is really an afterthought in a lot of cases. You know, you know, at some level we've gotten to a state where APIs are super important, but the people who built the APIs are surprised that they're that important. So we haven't had any sort of, you know, in terms of development community, grand standards that have developed in a, you know, well thought out manner on how everybody agrees RESTful services should be authenticated and protected.
Exactly.
There is stuff for SOAP, obviously, but SOAP is not the popular mechanism for interacting with cloud services anymore.
Mm-hmm.
And what is the popular mechanism these days?
Yeah.
Well, it's RESTful APIs. So
Okay.
using basic HTTP get, delete, put, post, head, and other verbs to interact with the cloud directly using HTTP rather than some sort of grandiose wrapping protocol.
Mm-hmm.
SOAP is more of an object-oriented sort of approach, whereas REST is more of a, I guess a functional approach, for lack of a better term, and I know I'll get skewered for that
Procedural.
But yeah, procedural.
Now, George, this is Tim Pearson talking. I'm more of a security researcher, and I've kind of pulled apart some of the stuff that they're doing. And, when they talk with the, your regular vSphere, they're still using SOAP. Do you expect them to change over to REST? You expect?
Well, that's vSphere, and I think vSphere is going to sort of stay the way it is. But because where VMware wants to go is they want you to interact with vCloud to do cloudy stuff.
Exactly.
Now, the problem with vCloud is that it is using username and password of this, the same username and password you use to log into, your vCenter console is what you use for API access.
Mm-hmm.
And that is like one of the number one worst practices of RESTful API design.
Mm-hmm.
And there's a whole bunch of reasons, starting with, in a lot of cases when you're talking about consuming APIs, you're not talking about users consuming APIs on behalf of a web client or an iPhone app. You're talking about third-party systems consuming it on behalf of any number of users. So, say a cloud management tool that is interacting and provisioning services on behalf of users of that service who may not be even interactively engaged and may not actually be people. So, the first problem is that traditional ways of doing authentication don't do a good job of separating between people and systems and the different types of access control that are needed for those types of systems. Then the second thing is the mechanisms. So in terms of identity, they've got a problem, and username and password is built around the idea that you're authenticating users, and that users are limited in terms of what kinds of what kinds of things they can remember. So usernames and passwords are, by their very nature, easy to hack because you need to have, relatively easy to hack because they need to have the ability for the end user to ultimately remember their username and password. No such constraint exists with system-to-system access, so there's no reason to limit, to username and passwords. Using API keys is a much better practice.
Yeah.
Well, even those API keys, let's think about that one for a second. All API keys has become is yet another way of doing username and password. Instead of doing one, we're now using two.
Well, it depends on what you're doing with those API keys. Now, with username and password, because they're so short and weak, you essentially have to use them.
Who said username and passwords have to be short and weak? Let's think about this. API keys are really nothing more than usernames and passwords, just bigger.
Not necessarily.
Who said that I have to have my username and password be 8 characters or 16? Why not 64?
Well, they can be, but the thing is that usernames and passwords still, for the most part, have to be memorizable by users. That's ultimately why username is something that is familiar to somebody, and passwords end up being 10, 15 characters for most people. And
right.
We can talk about
write it down and so on and so forth. Yeah. We're familiar with all that.
Unless they use passphrases. I've been fighting. It was an uphill slog all the way. Don't use a password. Use a passphrase that you can remember and make it as big as you want.
Yeah, we could talk about all that, but the practicality of the matter is people do use shorter passwords, and thus using that for API access when we're not constrained by that is problematic.
Well, again, I mean, when I do programming for AWS, for example, I have my key, which is 16 to 32 characters.
Yep.
And then I have my secret key, which is much, much longer than that.
Yep.
Somewhere in my code, I'm putting both of those.
And then putting them together somewhere to come up with, that's a good idea.
That's the second bit of it. No, but that's the second important point of this is that you don't do authentication by passing in the access key and the secret key. You sign the request with your secret key, and you only pass in the access key. So that's the second bit. You can't meaningfully do signing with most username and password schemes. You need something a little bit longer to make it a reliable signing mechanism.
Can I ask that question about this, guys?
Please,
this is Eben. So I thought that there was an idea of getting a token, which is available for like a period of time, say 60 minutes, and that allows you to then use the tool for that period of time. And so typically, if you're provisioning a new VM, for example, do that.
Some clouds do that, like OpenStack. That is the primary mechanism. Now, underneath the covers, the initial authentication may or may not be username and password, but whatever your initial, the authentication piece is separate from the individual authentication of calls. So you authenticate first, you get a token, and the initial authentication can be username and password or API key-based. You get the token back, and then when you make subsequent calls, you pass in the token.
So you go, okay, so here's the other thing is that with this proliferation of APIs, and we can get keys and so forth, if we're done right, to do the right access security, doesn't necessarily mean that the APIs are actually heavily encrypted at all.
Well, and so that's the second piece, is that I believe APIs should be designed so that they can operate over plain text, and not that you should actually implement your APIs over plain text, but that the reality is that when you get into a lot of different developmental context and proof of concept context for private clouds, in reality people are either not securing their connections with SSL, or they're doing it with self-signed certificates that aren't set up to be trusted.
Okay, so let me make sure I understand. This is Tim talking here.
Yeah.
Make sure I understand. So what you're saying is that somewhere they're coding this in their script or what have you that would not be protected. Somebody could just go in and view that script is the norm. Then it's up to the other person to use IPsec or use self-signed certificates or whatever to ensure that it remains encrypted point to point.
Well, I'm not talking so much about the encryption of the what's in the scripts. I'm talking more about, let's say I'm setting up a proof of concept private cloud, and I'm being lazy. I just want to get things going, so I don't want to deal with SSL certs. So I'll set it up, and all the API communication will be going over port 80.
Okay.
I'm saying that your API should be secure enough to allow communication over port 80 in a secure manner. I'm not saying that it's a good idea. For other reasons, it's not a good. I'm not suggesting it's a good idea to deploy a cloud that is not using SSL. But I am saying that when you're designing your API, you should make it be tolerant of not being deployed over SSL.
Okay.
The distinction is making sense.
You're basically saying it should be using a hash as opposed to a clear text password of any kind. And then they would have to break that hash, and then one more layer, which is defense in depth, would be the self-signed certificates and or IPsec and so on.
Well, see, that begs the question. I mean, I'm not talking about authentication. Let's say I do that. I create a session. I'm on port 80. I've already hashed all my passwords. I've sent them in as a digitally signed hash, whatever I want to do, and said, yep, I'm authenticated.
Yep.
That's well and good. Now I start sending commands.
Mm-hmm.
Someone can just easily get in the middle of that and send their own commands. So it almost sounds like you actually have to send the commands in a hashed form or some form of encryption of some, either hashing or redirection or encryption. You got to do something.
The requests need to be signed. That's the first thing. I think you need to do request signing as part of your API design, and you need to build in a second layer of encryption for sensitive data that may get pushed in your payload.
Okay. Exactly, and a lot of people, I think, find saying, you just got to run it over SSL as a cheap way to do that, a cheap and inexpensive way to do that.
And it doesn't work.
Well, it does work as long as everybody says blame self-signed certificates, and George, I'm going to pick a bone about that one because, hey, I trust some self-signed certs.
If you
look
know
at the federal government.
The cert.
Look at the federal government. The cert that's on a CAC card is self-signed.
Okay. Again, back to my point. If you know that for a fact that is the cert, you're fine. There's nothing wrong with self-signed certificates.
Exactly. As long as you
from
know
a security
the results,
perspective, it's not. But from an operational perspective, they're painful. And
again, there's no. Let's not say self-signed versus otherwise. If the cert, if the root certificate is in your cache, you'll never see it whether it's self-signed or not. You'll never see an error or anything like that because it's in your root cache. Everybody's happy with that. The only time we see problems is when the root of the certificate is not in the browser cache.
Yeah, I guess. So self-signed isn't the problem. It's the use of untrusted SSL certificates. That
sounds better.
Okay. And the reason I pick on self-cert is because I rarely encounter enterprises that have bothered to go push the signing chain out to however they've managed to set up the trust to actually push it out to all the clients.
Mm-hmm. So you're talking about when they're logging into the VIC specifically, or are you referring to something else?
Oh, anything.
Because 95% of the people still ignore.
Yep.
Well, that's just one particular example, but everybody.
This isn't an ignore scenario. I mean, good API clients, if they don't trust the SSL certificate, will fail the operation, and that's another piece altogether. Is they should fail the operation if they don't trust it. The problem, again, from a defensive perspective, is there are people out there that have written clients that ignore that have designed to trust untrusted certificates. And so again, by designing the API to be tolerant of going over plain text, of being tolerant of man-in-the-middle attacks, can deal with those scenarios.
Just to give you an example, one of the attacks I'm working on is an SSL Strip for the web interface for VMware. If you're familiar with that, SSL Strip basically makes it to where it's HTTP, but the end user doesn't notice anything. They'd have to look for that S at the very end, and everything else is perfectly normal.
Well, okay.
And a good example of an API that meets these criteria is Amazon's Ec2 API.
Okay, let's get back to what we were talking about. I'm sorry.
Yeah. No, I didn't. Sorry, I didn't mean to. I was just following on with the chain of thought about. I'm sitting here talking about theoreticals, and I wanted to bring it, into something concrete. The Ec2 API, it's a signed API, so your requests are signed. There are protections against, injecting your own parameters into the mix, against replay attacks, and ultimately, no sensitive payload is ever exchanged. That if you viewed it over plain text, there's nothing important you could do with it. Now, in Amazon, you could start arguing that the IDs themselves are important, and I would agree with that, and that's why you should never deploy over SSL. But over plain text. But again,
okay.
this is about being defensive. This is about being defensive against environments that have been deployed in plain text or been deployed with untrusted SSL certificates.
Mm-hmm.
And so Amazon's a good example of that, but Amazon's had a huge amount of time to think about this.
Yes.
And who's the worst example of this?
Well, I don't know if I want to pick on anybody. I would say people who are using username and password with, I've seen in the past people do username and password over plain text. I can't remember, who that was.
I can tell you right now, there's a site you can go to. It's called plaintextoffenders.com. And it basically shows you all the people that store their passwords as plain text. And the way you can tell is you ask to have your password reset. If they send you back your original password, there is no way they're hashing it.
Oh, yeah, yeah. And I'm talking about people who are accepting it, as part of the authentication process over port 80 rather than SSL. And not even getting to the point of how they're storing it.
Gotcha.
In there. I'd say the next worst case is people who are using username and password with HTTP basic authentication.
Well, and I can go even one further. I mean, think about things like PowerShell scripts and Perl scripts that are out there that do automation today.
Mm-hmm.
They take a username and password, but they also communicate over some API in a lot of cases that may not be related or protected.
Yep.
In other words, it would be interesting is if we went the way you were going, if I went to, for example, any type of cloud management suite and I said, generate me an API key, that would be better than saying, oh, I can log in with any username and password.
Right.
That's what you're getting.
Yes, absolutely.
So if I was using OpenStack and said, give me a cloud key, an API key, well, they should be able to do that.
Yep.
I'm not sure they do. I've never even
looked
into it.
Well, actually, that answer is complex because some implementations of OpenStack use a username and password for the authentication, and others use API keys. But in both cases, they're passing both the secret and the public part over the wire, so they don't necessarily, even if they're using API keys, they don't meet the criteria I'm talking about there. But, obviously still using API keys is better because it's all truly random data, whereas, the username and password is anything but random. Yeah, but, when you look at the world of cloud, going back to what we started with at the beginning, is that there just isn't any accepted state-of-the-art in terms of procedures. I mean, I've mentioned some people using username and password, some people using API keys with request signing, some using them by passing the secret keys. We've talked about basic auth, people doing digest authentication, and there are other mechanisms as well that I've seen people do that I can't think of off the top of my head. The bottom line is there are about as many different ways to do authentication over REST as there are REST APIs.
I got a question. After you fix your authentication, you get that secured. Is there a way to do a lot of cloud providers do a good job of showing where the API requests are coming from, or does that matter? Is there maybe ACLs on who can authenticate, or how do you control that and monitor that usage of your authentication?
So, some clouds provide, first off on the ACL side, some clouds provide, ACL controls so that you can say that only, these IP addresses or this range can actually make valid requests. Most do not. And then some will provide some level of audit trail, but again, most do not. The where we are in terms of where people are thinking about, just basic access controls and audit controls over API access is very rudimentary today.
Okay. Are there any companies that are doing it right that we can talk about?
Well, we have been.
I can't think of anybody who's really gotten it right, to be honest. I mean, I guess I would say I think Stratus has gotten it right, but you know, because you know, one of the things at least that I've had the advantage of is I've learned from how everybody does things that I don't like them. So all the things that I complain about on Twitter and here, for the most part I've addressed. So we have full traceability of API calls in Stratus, and we have request signing and API keys. We have the ability to distinguish between users, people, and third-party systems and all that stuff. But that's standing on the and probably not so much standing on the shoulders of giants, but learning from everybody else's battle scars.
Right.
Right. So George, so far we've just talked about the authentication of the API.
Well, I'm actually not concerned about the authentication, to be honest.
Well,
I'm concerned about the API itself. There's a lot.
That's what I was getting at.
So when we talk about the APIs that are involved here, I'm thinking about not only the authentication to allow me to have a session and how long that session lasts, but I'm also thinking about the command structure and how someone could break into that command structure doing a man-in-the-middle attack. And, those are very, very common attacks, and most people say, oh, no, they're not. I mean, I was on the phone with somebody, and they said, let's just sell man-in-the-middle, and any man-in-the-middle we're not responsible for. And, they're a security company.
Right.
So this begs the question, George, how, or anybody, I don't know if George has to answer this one, but anybody, is that how can we prove that the APIs of a cloud service provider that are using are actually safe?
Can I answer that? Because I read this article that was
Hold on a second,
fantastic.
Tim. I hadn't finished.
Okay, good. Sorry.
Thank you. My concern here is that from an auditing perspective, first off, I think this is being completely and utterly overlooked. Would you agree, George?
I think that definitely not enough attention is being paid to it. I wouldn't say completely overlooked, because I think we worry about that quite a bit.
Well, you do,
yeah.
And I know Amazon does, but the tenants don't.
No. For the most part, the tenants are, their view of the APIs is it's really annoying that they have to go figure out what their API keys are and then copy them over to their client tools, and that's where their awareness of what's going on ends. Now, that's not everybody. That just tends to be the users of cloud, but keep in mind, cloud, what has driven cloud is the end users, not central IT, that tends to think more about these issues.
Yeah. So once we get to the point where we're using these APIs for mass automation, whatever we're doing, how do we verify in any way, shape, or form that they're actually using secure mechanisms?
Well, I mean, if I were developing standards for an organization, I spend a lot of time just, 5 minutes ago talking about how important it is from an API designer to design defensively and make sure that you don't need SSL. But if I'm on the other side of the fence developing standards for APIs that we're allowed to consume, number one would be that it must be go over SSL using a trusted SSL certificate. Second thing is that I would demand that the clients fail on untrusted SSL certificates. So if you've got, and that's the harder piece, it's the clients, because you have so little control in the end over what clients people are doing, and it's so common out there to see clients that are written, even though let's take for Java for example. By default in Java will fail trying to make connections to an API server. That if you're using something like the the Apache libraries, they'll fail if they try to make a connection to a server and there's something wrong with the SSL certificate. But so many people write stuff to get around that and force trusting. And how do you, as IT, know which clients people are using to consume the cloud services that are doing that bad practice? So
the thing is that when you think about that one, you're talking about designing around SSL. Well, the SSL is horribly, horribly weak. I mean, think about it. I mean, Tim, how many attacks against SSL?
Right, but we need to understand it's not SSL, it's how it's implemented.
Right. Yeah.
Okay, would you buy that? Because, Ed and I have gone to the mat on this forever, I think, right?
Yeah, I mean, I agree. It's not SSL, it's how it's implemented. I mean, there's a whole another issue about root certificate trust, and, you know, if you really wanted to be anal, you could go down the route of self-signed, which is, if done right, is more secure, but, people doing it right is really, really, really hard, and, certainly the exception rather than the rule.
Mm-hmm.
So the next best thing is using, some certificate signed by some trusted root.
Yeah, but anyways, the trusted roots get broken into, and then they're no longer trusted.
Yeah, I'm not trying to say that that's, I'm not. I believe that that's a nightmare waiting to happen. So don't mistake me as saying that. Already has happened, but didn't blow up as bad.
Yeah, did you know, Tar?
Yeah.
Wouldn't it be better instead of designing around SSL to be designing around a secure public key infrastructure?
Well,
public-private key infrastructure.
When I'm
whatever
talking about
that may
the API, at the API level, I'm just talking about being defensive so that you can tolerate the least secure deployment environment.
Yeah, if you build the public key
right.
infrastructure keys and mechanisms into your API, as you said, digital signatures and or encryption at that level, and you just send MD5 encoded hashes across, MD5 or some form of UU encoded or whatever you want to use, base 64 encoded, encrypted strings across the pipe. Whether you do it or it's done externally to you, it's still happening, so you can use any protocol you want to use to transmit the data.
Yep. But the thing is that again, if we're moving to the other side of the fence and talking about how does IT make sure that their use of the cloud is secure, and especially of APIs, the reality is that the APIs out there are in various stages of being okay. So what are the steps that you need to take to make sure that you provide maximum access to the cloud with minimal risk to the organization? And setting up the API must be designed defensively as a requirement is going to limit the number of clouds you can interact with, because very few APIs follow that mantra. Most of them are designed that you have to have SSL as your trust mechanism and your encryption mechanism. And
I would agree with you there.
So if that's the case, you need to the starting point is to mandate that interaction with these cloud services has to go over SSL signed by some sort of trusted authority. Or
through some form of encrypted tunnel.
Yeah.
SSL, IPsec, no one cares.
Yeah.
Pick your favorite encryption tunnel and use it.
Yeah. As long as it's end to end and not just part of the pipe.
Correct.
Because I think that's an essential place to start.
Yes. Yeah.
And then you start to get what I'm saying.
But when you start there, again, as a tenant, should I be concerned?
Should be, but they have no idea.
Well, yeah, and the next step on that is I would demand of my client, and the problem is that you can't, again, if you try to set this up as a standard, you're going to end up with a very small population of clouds you can interact with. But I definitely would push hard on cloud providers to provide access to audit trails on requests made against our API. I mean, and it's not just a security issue or a forensics issue. It's a troubleshooting issue as well.
Aman is our audit guy, and have to kind of text this in. But the problem with auditing is it's expensive to have somebody come in and do an audit because it has to be independent.
But I'm not even talking about that.
One at a time. Even you first.
Yeah, I was just I think we're saying the same thing. Tim, we need to provide the capability to provide an audit. We're not saying that we have to provide audits. So one of the questions I was going to ask earlier, this has been a very interesting and intriguing conversation so far, is there, you guys have a wealth of knowledge on this stuff, but as a consumer, where can I go to get the latest information on who is, doing well? It's sort of like I want to assessing these guys, or where the best. We ask you.
Hold on a second.
Okay.
One answer. I heard three people. George, can you go on, please?
Well, so on the where to find this information, I'm not aware of any place from a Cloud API perspective that it currently exists. However, I have decided that because of the stuff I've been doing with the open source Dasein Cloud, which allows Java access to a whole bunch of different APIs, that...
Can you repeat what you just said? Sorry, the stuff you're doing what? Can you just repeat what you just said or elaborate a little bit more, because I'm not familiar with that?
Okay, so Dasein Cloud is an open source, it's on GitHub Java library that's an abstraction. So you write once to this Dasein Cloud API, and then it lets you talk to all the different cloud providers out there over their REST or SOAP APIs without you having to know whether it's REST or SOAP or all the details about authentication or their, transport protocols or whatever it is.
Okay. So this is a project on GitHub that I can check out, and it's DOS, like DOS, on
it's
cloud?
Dasein. That's a German philosophical term, DASEIN -cloud.
DASIN -cloud. Thank you.
EIN.
EIN. DAS, Dasein Cloud. Gotcha. And you got to say it with that German accent, right?
Dasein Cloud.
All right.
So because, and so in the course of building this, I've, written stuff to talk to 2 or 3 dozen different cloud APIs, and so, which has led me to write the book and be opinionated on cloud APIs and all this stuff. And so we're actually working on a benchmarking suite for that, and we're going to do some comparative stuff around, comparing different aspects in a quantitative fashion of, including, security, performance, chattiness, things like that, of the different cloud APIs. What I don't want to get into is writing something that's all my personal opinions on stuff. I definitely want it to be, judged against very specific, concrete criteria. And so that, I think, will not only serve these security questions you're asking, but a wider variety of questions as well.
Awesome. So you're sort of providing a tool and a framework for gathering this information in an objective fashion without human subjectivity coming into it, right?
Right, exactly.
Now,
That's wonderful.
is this something that enterprises would want to use on their own, or do you see any possibly leveraging this technology in more of a community or open source type of thing? Where are you going with this?
I think this is very much a community open source thing. I mean, definitely enterprises would be consumer, at least if nothing else, of the resulting reports that come out of them. But I do see it as being very much a community effort to keep it going.
Yeah, because right now, if you ask a cloud provider, are you sure or you're secure? Have you done your audits? What do you think they're going to say? No.
Well, no, not only that, I don't. This is and we can get into this in the second half, and I think we've gone down this path, and I think this is a new, interesting approach. Is that, and this is another question for the community, for the panel, is that does it make a difference if the cloud has done its audit, when the ultimate responsibility of the compliance is actually the owner of the data?
Exactly.
And the reason why I ask this question is that I've been told there's some PCI compliant clouds over there, well, they won't tell me what's in scope.
Yeah. Well,
it's useless unless I know.
I've always been of the belief that, I mean, obviously you want the most transparency and the greatest commitment to security from your cloud provider, and one of the best ways to do it is to look at how they've been certified and audited in the past. But ultimately, your security practices around how you consume cloud need to be such that you don't need their assertions to be true or their certifications to be true. You should be able to be secure in the least secure cloud if you done your job right.
I want to, if I may, I'd like to ask you, Ed, I think I'm going to get you some details here. This tool seems like it has different modules for different cloud providers, and it might be the case that I use this tool to test the way my access is to the cloud providers I'm using. There needs to be some, I would assume I'm putting the API keys and passwords or what have you into this tool so that it can in turn go to the cloud provider and test it. Yep. So my results might be different than Ed's or Tim's, right, using the same tool because they have configured things differently at that same cloud provider. So you got Amazon, Joint, GoGrid, IBM, all sorts of things, right? And so it's not just what that cloud provider offers, it's also the way it's configured.
Absolutely.
Is that not true?
Yeah, and it also, it tests some of the, integration tests it does in addition to, being able to detect how your account is configured. It can also detect, you'd be surprised, but we've run into situations. So, among the tests are testing with a valid username but bad password or a good password and bad username and seeing what happens. And believe it or not, we've encountered more than one situation where passwords weren't actually being checked. So, those are obviously valuable things to know about your cloud.
I would say yes. And then, okay, given all that, but we're starting with some auditing capability here, but should the standards change at all? Should the next PCI compliance for virtualization and cloud change to also include audit? Also include API security and verification?
There's some stuff that I was involved with a couple of years ago, and because I've been so busy, I haven't been involved lately, and I don't know where things stand now. But I know Chris Hoff was leading an effort that's now been rolled into the CSA called Cloud Audit. And one of the things we had talked about was bringing that together with Dasein Cloud to do exactly what you're talking about, to leverage that to do some level of assertions around what the cloud is doing from an API perspective.
Yeah, I was actually involved with Cloud Audit as well.
Okay.
So now we got...
The false passion is, what drives things a lot of times, I think.
What's that?
And now we have CSA Stars supersedes Cloud Audit, or is a subset of Cloud Audit. But I'm thinking about the bigger compliance documents. I'm thinking like PCI, because I know they're working on their next version. It's going to include cloud and all that. So the question should be, should those organizations like the PCI community or committee, when they write the next PCI DSS, also put in their API security issues?
I would think that anybody who's tried to consider the impact of cloud on whatever kind of cloud you're talking about, but in considering the impact of it on whatever their compliance framework is, really should think about the API.
Okay, so let's say we do that. Is there any cloud today that would pass the audit?
Well, obviously it depends on how you phrase the controls.
Absolutely.
I think, Amazon, for example, does a good job around that. So I think, they would be successful in whatever structure you came up with. When it comes to private clouds, obviously, there are going to be ways you can deploy your private cloud software that is secure and ways you can deploy it that isn't secure. So it's going to be more than just the software itself. It's going to be how did you deploy it and what controls did you put in place as, the provider of your own cloud services.
Okay. And so what about, so this is again a question to the whole panel. Now we have a bit of time left, and this is our last podcast for the year, for 2012. And what do you see as happening or changing in 2013 that would make a huge difference? Now that we've gotten past 12-12-12, we can breathe a sigh of relief and go on with our lives. So what do you think? What's going to be big next year? Stephen?
My big thing is we're seeing a lot of companies migrate either to the cloud or they have existing clouds and they're looking to maybe lower cost, increase performance, or as they interact with other organizations, extend those clouds. And so we're seeing a lot of more heterogeneous cloud adoption where you need to have resources in multiple clouds. And this is raising a host of security issues and other issues, interoperability, performance management, et cetera, where you don't really know what you have because your standard tools for working in one environment are not going to equate equally to the other environment that you're starting to use. So what I see for next year is more standards, actually, which will help to make sure we're on the same page when we look at various cloud and even internal infrastructure solutions. So I see a lot of more interoperability testing and standards being used by companies.
Okay. Anybody else?
I say it's going to be culpability. I think it's going to be the person who's responsible. In other words, proving it was them that did this, and that goes back to auditing, because there's not really a good way to do it other than the cloud provider doing it. And isn't that kind of like having a fat kid watch the pie? Of course they're going to say, yeah, of course we've done this.
Well, be careful about that because some recent lawsuits, you can't say that anymore, Tom. Change your phrase about watching the pie. The birds watching the pie.
Okay, the birds watching the pie. Fine. I'm just saying it's if, for example, if Reagan were to ask Gorbachev, of course you moved those missiles. Why? Of course, comrade, I did. It would be his answer. We've got to have a better way of being able to verify, and verify at a low cost from a third-party person or script or one that has been signed by somebody that we trust to know that it hasn't been changed or something along those lines. That's my take.
Okay. So that's what we need, but what do you predict is going to happen next year?
I mean, I'm not really asking for a lot there, I don't think.
You're asking for an awful lot. I could not see some script writers digitally signing anything. And the people that use, I know a couple of people, they have scripts that are used day in and day out by hundreds of thousands of people, and I don't see those being digitally signed at all.
Okay, well, how about if we just simply hash them and check the hash before we use it?
Again, that's something we would like, but what about a prediction for next year? I'll come back to you. Think on it, Tim.
Okay.
George, what do you think is going to happen next year? Well, I mean, I think that's, of course, I'm very focused on the cloud, and I think the big nightmare in the cloud right now is the way everybody is doing networking. It's very immature and a lot of messy, different models on how to model networks in the cloud. I think with all the focus on SDN and and trying to mimic what's going on behind the firewall in public clouds. Hopefully we'll see that evolve, and that evolution into something is going to raise with it a whole bunch of security concerns probably only a few of us have thought about to date.
And if you think about SDN, I mean, there's 5 competing protocols right now. I'm assuming that next year there may be even more.
Yes.
I mean, the big question is, who do you think is going to really win in that?
You know, I've been asked that this week probably 5 or 6 times, and
I haven't come. I've been thinking about it for a while, and to be honest, I can't come up with an answer.
Oh, my answer is that it is so ridiculously early in the not just SDN, but just the whole way you think about networks and cloud computing is just so I mean, cloud computing in general is immature, but if cloud computing is a toddler, networking in the cloud is still a fetus. You know, and so picking winners right now is insane.
Well,
because
I got an answer for that.
Okay.
That's like answering the question, who's going to win the operating system wars, 10 or 20 years ago. I mean, there's going to be many winners, right?
No,
yeah,
Unix.
Yeah. I think it would be more like asking it in 1977, to be honest. But
Novell.
Hey, in 1977, the Carnegie and Ritchie and those guys, and they would, and Weinstein and all those guys, they would have absolutely said Unix.
I'm not entirely sure that's true, but
I'm sorry, Plan 9.
It at least would have been one of the answers, which you can't say is true of anybody else.
That's true. At least back then. And I think I agree with you. I think that there is just too many decisions to make right now to make it worthwhile. I think the clear winner of the cloud is the one that can adopt the most standards, the most protocols, and allow you to interoperate with all of them.
Well, I think the key to success is really to enable a world in which the idea of application infrastructure and network are packaged together and redeployable in any context based on immediate needs. And that's not just a technology problem, it's also an idle problem and a people problem, and a whole bunch of stuff goes together with it. But
so you say application and networking.
Yep.
However, it seems that when I talk to a lot of people, and this is just one thing, a lot of people just leave security out there. Is there a certain assumption that you're seeing that application and network already are secure?
Well, so, my worldview is, or at least the end game that I think we're going to is, is somewhat influenced by the DevOps view of things, that infrastructure is code. And that means
there's my name.
DevOps. That means that in particular, that your network configuration is part of the application configuration, rather than the world in which the network is something that pre-exists onto which you deploy applications. And that that may sound like semantic nonsense, but the point is that when they're bundled together, when the application is not divisible from the network, you get the ability to to fail in spectacular ways and recover rapidly to wildly different environments. I can, replicate my AWS network over in Rackspace or somewhere else based on.
But again, I think you missed the point. I missed the point of the question. I understand bundling application and network together, and I think that's great. But where's the security in that?
Well, security is part of that definition, and not in terms of
right.
In terms of a lot of stuff we talked about today, but more in terms of policies.
Policy is such an overloaded word. Let's be really specific here.
Well, things like
your security controls,
for example. I'll take that as a very simple one, saying that this data is governed by these jurisdictional constraints and making sure that the physical architecture to which this is bundled is, only deployed in Europe or whatever. And,
But then, okay, so with taking that example, shouldn't your bundling actually be application, security context, and networking?
It's all of the above.
As well as jurisdictional?
Yeah.
But jurisdictions are part of security, so.
Well, I guess, what I'm saying, jurisdictional both goes into security and general governance.
True.
Yeah, but what I'm saying is that I'm just giving an example of, for instance, of a policy. I mean, the policies may be defined by a compliance framework. So you say that this application must be PCI compliant, and the important thing is that the person deploying the application doesn't necessarily know what that means. The application is able to understand that it needs to be PCI compliant. It knows what sort of basic networking it needs for the different components to talk to one another, and it's about the mechanisms that are doing the deployment to actually make sure that given the needs of different components to talk to one another, that those communication pathways are set up in a way that is going to support the PCI compliance.
Because PCI doesn't go with a particular application or with a particular machine. It goes with the entire package, I think is what you're trying to say, right?
Right, yes.
Well, and I'm actually
but there are certain machines, that's a good example. There are machines that are identified as being part of a PCI scope and so what's happening more and more with cloud is that there's metadata being associated with the machines, and it's policy-driven, and now because of the software-defined networking, you're going to have software-defined security type of tools. You can have certain policies and controls that are actually enforced through automation. And I think that's where we're going here. It's not just networking, but that's one of the key components that's been not automated when you provision a new environment.
Mm-hmm.
Well, and I actually think, we keep on coming back to compliance. And okay, great, we need to be PCI compliant. Yes, that's governance. But you know what? To be honest, compliance is not security, and security is not compliance, and we never should equal the two ever. Because I can be PCI compliant. I'll guarantee you, if I am, my security is horrible.
No, but be secure is never a requirement, or it's always a requirement, depending on how you look at it.
I think it's always a requirement.
Well, my point is that there is no, item that you say I am secure or I am not secure. It is I have these specific things that I need to manage from a risk perspective, and PCI encapsulates governance items, it encapsulates security items. Being PCI compliant doesn't mean that you're secure, but the end business requirement is, for the example we're using here, the end business requirement is that this application must be PCI compliant. There may be a whole host of other things it must do too, both from a security and a governance and just general risk management perspective, but I was using PCI as an example.
But I think a lot of people are concentrating on compliance that's where they're spending their money, as opposed to real, true security.
Yeah, and I guess the point I'm making is that you're never going to say when you're deploying an application, this application needs to be secure, because there isn't anything an automation tool can do with that information. Okay.
I would agree with you there. Now, Aman, from Malaysia, was saying he thinks we'll see a plethora of products out there that will allow cloud consumers to retain their security posture while engaging with insecure cloud service providers. And I would agree there. I think we're going to see a lot more companies besides Voltage and Cloud Cipher come along. Anybody else have a feeling about that?
Well, I'd say I put Stratus in that list.
Well, in Stratus, okay.
I think that's almost a given, Ed.
Well, it has to be. We've already seen it over the last 4 or 5 years that people are coming up with Cloud Cipher and Voltage, and all these tools are coming along. But I think there'll be a real push. This is my prediction. I think that there's going to be a lot of education over the next year that the tenants have to be concerned about their own security, and that the security posture of the cloud service provider really doesn't matter, as long as it meets the
internet, right?
requirements.
Yep, exactly. Like the internet.
You know, the internet is supposed to be untrusted. It's you that should make it secure by the things that you do, not rely on X, Y, Z or.
But I think before that happens, there's going to be some clouds that fail spectacularly.
You know, that's the unfortunate truth, Ed, and you're right.
I mean, it's going to be some spectacular failures that are going to be career limiting for a lot of people, and I wish we could do it without having that happen. I wish we could.
And I really wish it not be my career.
And all we can do is educate the market. Well, George, thank you very much for joining us. It was a very interesting conversation. We are at the end of our hour.
Yeah, it's been a great call.
And hold it, before we go, last thoughts, anybody? George, your last thought.
I don't really have much of a last thought, except I do think it was a very interesting conversation.
All right, thank you very much. And we will see everybody in the new year. Hopefully you guys can join us. We are going to be at episode number 99 as we move towards our 100th episode. And even brought up the link, and I will put it in the show notes of the I can never pronounce that. Even pronounce it, please.
Dasein.
Dasein Cloud.
Dasein.
Dasein.
There we go. Everybody can look at that. We'll put that in the show notes. It's up on GitHub. And that would be kind of cool if people wanted to pursue that. I'm sure George would like some help on it.
Yep.
Yeah. Look forward to it.
Absolutely. Well, thank you, everybody, and have a great, happy holiday.
You too. See you guys.
Yep, you too.
Thank you, George.
All right.